so we'll turn to Rick, who's been running an experiment in everybody's full view for a number of years. For those of you who are not familiar with Rick, I would direct you to a lot of writing that he has done about T-shapes and about the practical challenges of bringing broader skills to an engineering discipline. And Rick, I wonder if you'd tell us a little bit about the Olin experiment to catch some people up who may not have watched every episode of this opera, as well as then what works and what lessons should be taken.
Sure. Well, first of all, let me say it's a real privilege to be here today. This is a community of like-minded people who care about breadth of education, and I just feel very humbled to be in front of this group and also to be on this panel with like-minded people. I am delighted to see Christina join our community of radicals who are willing to blow things up and start over. You know, my wife has often told me I'm not smart enough to know how much trouble I'm really in, and she's usually right, so that's just my word of warning there. So I was the first employee of this place, Olin College. When I went there in 1999, it was not yet a place. It was an idea. There were 4 people who were the directors of the F.W. Olin Foundation, have a long history in higher ed. They are philanthropists. There are, in fact, 78 buildings on 58 university campuses that say Olin on them. One of them was the University of Southern California, where I spent 13 years on the faculty, so I sort of felt they knew something about education. But it turns out that none of them is an engineer, and none of them has ever worked in higher education. But that doesn't mean they don't have strong ideas about what needs to change, including such things as not having tenure, not having departments, students not paying tuition, and everything having an expiration date. So, you know, we dove in. The most important thing, I believe, that we concluded is the result of what we call the Olin Partner Year. And we're now visited by 640 universities in the last 5 years, lots of them from abroad. 2 or 3 times a month, people come with a blank sheet and a big checkbook, and they say, we're planning to start a new university in our country. How do we do that? Which is really daunting. The most valuable advice I think we give them is experimentation. We did this experiment back in 2001. We brought in 15 boys and 15 girls who lived for a year in construction trailers on the parking lot while the campus was being built. We didn't quite know what to call them because they were not taking courses, so we couldn't call them students. In fact, the IRS doesn't give them credit, or parents, for paying for this. They also weren't employees, so we just called them partners. And we said, we need your help because you can't pretend that you don't know how to solve the calculus problem and pick method A over method B as being more effective. You have to actually have people who've never solved the calculus problem and see how they react. That was the theory. We would do experiments about every 5 weeks, and we would design the experiments, and this is the key, we would design the experiments to fail. You can't design an educational experiment that involves real students taking classes deliberately to fail in any university that's taking tuition and offering courses. This is illegal. Okay? But they were partners, okay? So we tried stuff just to see what would happen. And that's where we learned amazing things that changed everything about the way we thought about education. The fundamental thing that we learned is that kids are way more capable than you expect. A lot of the things that don't happen right in education are because of our intellectualization about structuring it to prevent failure. And what we do is that we prevent creativity and we prevent growth. So I'll just give you one simple example of this. We sat around at the stage roughly where Christine is at now, imagining what could you remember from your undergraduate education? And it was stunning how little we could remember, except for the project. Everybody could remember the project, which led to the question, well, why did we all do it in the senior year? I mean, there must be a good reason, because everybody does it in the senior year. So we theorized it must be because you have to have 2 years of calculus and physics before you're qualified to pick up a wrench. I mean, it's obviously going to be true. So what happens if you ask students to do that immediately, before they've had any of the calculus and physics? So we asked them to do this. We gave them a challenge. We said, you have 5 weeks to design, build, and demonstrate a pulse oximeter. And they said, excuse me, a what? So we spelled out the name, and we said, this is a medical instrument that you find in the hospital. You know what's that thing they clip on your finger? It measures the pulse rate and the oxygen content in your blood. No, it doesn't stick a hole in your finger. It has a little light that looks through the skin. And they said, okay, cool, where do we learn about it? I said, why don't you go to the internet and start with the patent literature, because the person who invented it has to have a little schematic diagram and a little explanation. So we said, okay, there's a shop over there with some tools, some stuff like transistors that you've never heard of. And we don't really care where you get the information. You can call your uncle or your aunt or anybody, but you've got 5 weeks and you have to make it work. Okay? Go. And at the end of 5 weeks, we're going to end this, sort of a mercy killing, okay? And we'll do the postmortem, and we'll find out where they got stuck on the semiconductor physics and so forth. We'll find out what happens if kids try to do things that they absolutely are not prepared for. But something very unusual happened. In 5 weeks, they had it working. We weren't really quite prepared for that, so we brought in a hospital version, and we put them next to each other and calibrated it. And sure enough, I mean, they were both doing the same thing. Really amazing. Now, don't get me wrong. No one in their right mind would want to buy this device that they built. It's kind of a miracle that the soldering was good enough that it worked. And they had a box full of fried transistors that had all blown up because they put them in backwards. And they had questions like, why does it have 3 wires on the back? All kinds of interesting. So these were not physicists, okay? But they got it to work. There are 2 things that we learned there. One of them is, no, you don't need to have 2 years of calculus and physics to pick up a wrench, okay? Have you ever heard of the Wright brothers? Okay. A lot of the most important technological advancements don't happen because the theory preceded the experiment. So experimentation is really important. The other thing we learned was even more important. It was the effect of this exceeding their own expectations on them personally. It was now as if they were 2 feet taller. And they had a can-do attitude. Now that stuck in our heart. We all went back to our freshman year in engineering. None of us had ended that year with a can-do attitude. In fact, it was closer to what we now call the math science death march. Okay? Can you survive the first year? Okay? If you survive until the senior year, we'll give you a wrench. Really not what we'd expected. All right, so that's number 1. If you're planning to start something new, don't forget to experiment with the very people that you expect to be involved. I don't care whether it's in Brazil, whether it's in India, whether it's in Saudi Arabia, whether it's in Singapore, whether it's in Massachusetts. That was what we'll teach you. We learned a lot from a very important mentor of ours, a fellow named Howard Gardner. I don't know if anybody's heard of him. He's a cognitive scientist at Harvard, and he explained to us that intelligence is more than SAT scores, okay? Intelligence has at least 7 independent components, and only 2 of them involve logic or language. And the decision-making process in humans has a lot more to do with context and with narrative than it does with mathematics. So we eventually developed a whole new definition for what it means to be an engineer. At our place, in fact, it's a banner that's over our library. An engineer is a person who envisions what has never been and then does whatever it takes to make it happen. Now, there are lots of other applied scientists who are really important people too, who explain what happened, but engineers are the people who envision things first and then make them, and the science comes in the making part. The important thing, it doesn't start with your math scores. Now, I don't know about you. How many of you in the audience are engineers? Okay, quite a few. I'm an engineer because of my math teacher in high school, who said, you're pretty good at math, so probably you should be an engineer. I don't know what they are, but you should be one. Okay? And what we've concluded is that engineering is more about vision than it is about mathematics. Understanding that is really fundamental. So, in fact, our whole concept of what innovation is different. I mean, again, this is part of blowing up the ship here. Be careful. Raised as a, good Boy Scout sort of faculty member at the University of California, we were trained to go every February and talk to our congressman and senator about increasing the NSF budget, because that's what makes the whole world work. I mean, don't you know? They send money to us at the universities. We create what I'd call just-in-case science. Some of it has applications. We throw it over the wall to the tech transfer office. They have some attorneys and apparently a jar of pixie dust over there, and they sprinkle them. And some of these things turn into companies which hire new people, generate new tax revenue, so you can send even more back to us. And almost everything important in the 20th century happened because of us in science and engineering. And so that's pretty much it. That's what innovation means. Now, I had this really weird experience of being a trustee at Babson College, which is across the street from us. I don't know if anybody's ever heard of Babson. It's a business school. It's known for entrepreneurship. They use the word innovation all the time. Can you imagine? This is a business school, and they talk about innovation, and they don't even have science. I mean, there's no NSF grants. So I'm thinking, I guess I'm doing penance from some future, life. And then it occurred to me, wait a minute, innovation is about doing things, framing things in such a new way that it changes the way people live. If you have a really profound innovation, it changes life so profoundly that people can't remember what life was like before it happened. Okay? So my kids can't imagine how the caveman lived before the cell phone was created. I mean, apparently it's always been here. And then it dawned on me, have you ever heard of the credit card? Do you think the credit card may have changed the way people live on the planet? Can anybody remember what life was like before the credit card? Maybe there's innovation that doesn't involve a Nobel Prize in physics. By the way, Apple Computer is very healthy. One of the major components of that is iTunes. iTunes is a business model that's changed everything in the way music has been distributed. And it's not about a Nobel Prize in physics. So maybe there is something to this business side of the events as well. And then it really occurred to me, one of our graduates is now pretty high up in the leadership of Facebook. What does Facebook sell? Have you ever thought of that? You can't buy one at the grocery store. I believe Howard Gardner was right, and so was Maslow, psychologist. Facebook sells an opportunity to tell your personal story to a group of people who you really care about. Who knew there was a business model in there? The way humans are wired, telling your personal story is the way you become the most important person in somebody else's life. And according to Maslow, the psychologist, the most fundamental need is oxygen. The next one is water. And then before food is belonging and being the most important person in somebody else's life. And what Facebook does is enable us to do that in a society where this is really largely inappropriate. It's very difficult to do. And so that's innovation as well. I know my kids certainly can't remember life before Facebook. If you're going to be an innovator in the 21st century, you need a lot more than math and science. In fact, the last thing I'm going to say here is the role for education in the 21st century, I believe, is to go beyond knowledge to address in a very deliberate, central way attitudes, behaviors, and motivations. That's what lasts. Who was it? I'm not sure if it was Piaget that said education is what's left over after you've forgotten everything that you learned. There's a lot of truth to that. What's left over is attitudes, behaviors, and motivations, and that's the ability to learn and the ability to make sense of the world. Every time you walk in the classroom with a piece of chalk to teach calculus, you're not just teaching calculus. You're teaching attitudes, behaviors, and motivations as well. And those are the most powerful things that we do because it inspires people and it changes lives. That needs to be central to what we do in education going forward.